Hi, I'm Austen Kaul, and today we'll be covering a non-inverting summing op-amp. First, we need to clarify the rules of an ideal op-amp. The first rule is that there is no current through the input terminals. The second rule is that voltage is the same through both of the input terminals. Here is an inverting op-amp, and here is a non-inverting op-amp. For an inverting op-amp, the voltage is inputted into the inverting terminal, and there is a negative gain. For a non-inverting op-amp, the input voltage is in the non-inverting terminal, and it has a positive gain. Today, we will be working with a non-inverting op-amp.
To solve the non-inverting summing op-amp, we are going to use superposition to find the voltages at V positive 1, V positive 2, and V positive 3. And you add these three up to find V positive, which is the voltage at the positive terminal. To find V positive 1, we deactivate V2 and V3 and use the voltage divider equation, which gives us V positive 1 equals V1 times the R2 and R3 in parallel over R2 and R3 in parallel plus R1. This simplifies down to V positive 1 equals V1 times R2, R3 over R2 plus R3, all over R2, R3 over R2 plus R3 plus R1. And when you multiply that by R2 plus R3 over R2 plus R3, that simplifies down to V positive 1 equals to V1 times R2 over R2, R3 over R2 plus R2, R3 plus R1, R2 plus R2, R3. R1, R3. And it's the same for V positive 2 and V positive 3. Instead, you deactivate V1 and V3. And for V positive 3, you deactivate V1 and V2. Which means that for V positive 2, R1 and R3 is in parallel. And for V positive 3, R1 and R2 is in parallel. And for V positive 2, you'll get a V positive 2 of V positive 2 equals V2 times R1, R3 over R1, R3 plus R2, R1 plus R2, R3. And for V positive 3, you'll get a V positive 3 equal to V3 times R1, R2 over R1, R2 plus R3, R1 plus R3, R2. We're going to use superposition, which gives us a V positive equals to V positive 1 plus V positive 2 and V positive 3. So using the three equations we found earlier, we can combine these three and then simplify them down. So V positive equals 1 over R1, R2 plus R1, R3 plus R2, R3 times V1 times R2, R3 plus V2, R1, R3 plus V3, R1, R2.
Using the answer that we found for V positive going into the positive terminal, we are going to find the V out, or the output voltage coming out of this op-amp. As we remember from our ideal op-amp rules, the voltage going into the non-inverting terminal is the same as the voltage that comes to the inverting terminal. So we will use our gain equation that we specified earlier for a non-inverting op-amp. We rearranged it to find that V out is equal to 1 plus R5 over R4 times Vn. And our Vn is this V positive voltage that we solved for earlier in the problem, giving our final answer of V out is equal to 1 plus R5, R4 times V positive.